So I'm going back to that a little bit longer example just a few videos back about the producing threads and the consuming threads, and let's just open this up a little bit. Hopefully you understand by now that we need to lock our structure, or lock on our structure, use it as our lock or our baton, lock it, get in, get out, do our thing, and that anywhere we want to access our shared data, which in this case is the shared queue, regardless of whether we're adding to it or reading from it, if we want these threads to play nicely in this situation, then we need to lock. We didn't need to do that in the previous example where I had all those numbers, 500 million numbers in an array, because we generated all the numbers before we made any other threads. And then when we did make the other threads, we broke, oops, well, I'll pretend that goes through there. We broke each thread into handling its own portion of the array. So they weren't necessarily reading the same data, and they definitely weren't writing any data. So no stomping on each other there. We didn't need to do any thread synchronization in that scenario. But in this scenario where we're producing numbers and pulling numbers and the various threads are trying to grab the numbers as they're being produced, we saw the exception explode, then we definitely need to do some thread synchronization, and lock is one of the built-in ways of doing it. Some programmers frown upon it. There's other various ways of synchronizing threads. I'll show you all of them. I'll let you make your own decisions as to which ones are appropriate to use where. We've already seen some issues with lock, that it's an indirect way of accessing the synchronization block. And there's also some other issues with it, hopefully I'll talk about. But for now, in this video, I want to point out something else with this queue. We saw in the help, let me bring the help up for queue again. I'll bring it up here on the screen. So I have the help screen here, and I noticed I actually pulled up, in the previous videos, I pulled up the help screen for the non-generic queue class. If I go back here, there's the help screen right below it for the generic queue class. And why this matters, it doesn't really matter for the stuff we were talking about before, but I noticed that the queue class has this, if I can find it here, Control F, synchronized, there's the property, all this stuff, let's go. There's this synchronized method, and basically what that means is I can pass a queue that I've created to synchronized, and it will return back a reference to a queue that allows only one thread in it at a time. Basically the same thing we're doing with our locks, except now we don't need to say lock ourselves. The queue's going to worry about it. It will only let one thread execute code inside of it at one time. Well, they didn't add this feature when they added the generic queue, and hopefully you remember that we want to use the generic container types and never use the non-generic. I can't think of a reason why you'd want to use the non-generic. They were just there for when we didn't have generics. But I don't know why they didn't add the synchronized feature to the non-generic container classes. I presume there's a good reason, but I don't know it. So let me just show you how you could kind of do this yourself. I'm going to go back to our code here, and here's the example. I'm just going to go to the bottom here, and I'm going to make a class and call it my synchronized queue of T. And we're going to be super lazy. I'm just going to have a private, but I'm not going to type private because private's the default. It's assumed. I'm going to say QU. Let's use the built-in queue. The queue. It's new queue of T. And let's say public void nQUE T item. All right, and we're going to say the queue dot nq item. And public t dq ue. Yeah, and right here we're going to say return the queue dot dq. And let's do the count property. Public, bring this up a little bit. Control down arrow is what I'm doing there. Public int count get. I wonder if I can keep this one line. Return the queue dot count, and hopefully you're realizing that I'm going to have to do basically anything I can say the queue dot on all these methods. I would have to basically do the same pattern I'm doing. And it's very cheap what I'm doing. I'm just passing the buck on to the internal queue here. Notice here I'm just reusing it. So scratch your head a little bit and say, Jamie, that's a total waste, and it is, except now I can synchronize. All right, I can be meticulous. I can say lock the queue here. And I'm going to Control L to cut that line, paste it. Whoopsie. I'm getting a little bit too ambitious. Paste it. Okay, Control L, Control V, and same thing here. I'll just type it, lock the queue. Alright, so everywhere I'm accessing this queue, I'm going to lock around it first. And I'm really using the queue as my baton for my lock, but I'm also using the queue as the wrapped object. So now you can instantiate. We could use one of these. In fact, why not? Why don't we? We can use this, and I no longer have to say lock around this if I use this type, because I know the type's going to lock itself. It's going to keep other threads from entering it. So let's actually change our example to use my synchronized queue. I'm just going to copy this, paste this here, paste this here. Let's build. See, oh, build succeeded. But now I no longer need to lock because I have this synchronized queue instead of my my non-synchronized one that I was using from the standard library. Let me look for lock in here. Oh yeah, of course we have locks in here. But then I want to get rid of this lock. Oh, actually this is an interesting situation. I can't get rid of this lock necessarily. Because what happens is we do the check, and then we go out and we do the dequeue. Alright, so yes, when we go into this count property here, I can F12 and yeah, that's nice and locked up. Very good job. And if I go into this dequeue method, yeah, that's nice and locked up. Good job. But there's no lock that exists right here. There's a danger zone right here. We let go of the lock here, and then we go to dequeue. We saw that in the previous video when everybody tried to go in and dequeue at the same time, and then that caused some issues. So, what are we going to do now? I have to be intelligent. You know, if I'm naive, and I used to be, and I still kind of am, I would have taken this lock off and just relied on the built-in synchronization. But I can't because I'm doing two separate operations. Remember that word atomic? We're no longer atomic anymore. These are now non-atomic. I need to keep them atomic. Well, alright, so what do I lock on? Alright, I can lock on numbers, but wait a minute. Let's collapse main here. And let's see. Oh, do you remember this trick? I can grab this and drag this down. Ooh, and I get two fonts. How fun. I'm gonna put the lock right there. I'm doing control scroll to get that smaller. And then let's go down here. I need to lock on the same thing that this class here is locking on. Ooh, yay. What is this class locking on? Well, I just determined I'm going to lock on the private queue. So how is this method, this sum numbers, supposed to access this private queue? I can make it public. I don't want to do that. You know, that has its downsides. So what else could I do? Well, what they did in the old non-generic class type is basically they made this public object sync root is what they called it, synchronization root, I guess is what they were going for there. Get, and I'm going to return what we're synchronizing on, public the queue. Well, okay, this is a little better because they don't, the consumers of this property don't necessarily know what they're getting back. They just know that they can lock on it. Okay, so that's a little bit better here. I can lock on, instead of locking on numbers itself, I can lock on its sync root. Alright, so now I've made this atomic. Good job, wonderful and lovely. But that just makes me, it's the same thing as, it's almost like I just made this public, except I kind of hid it behind the compile time type of object. So you know what, I'm actually going to be a little bit more strict, and I'm going to say, you know what, object baton gets new object, because really these objects are just those indirect things to those synchronization blocks that I showed in I think the video before this one. And then instead of locking on the queue, I'm going to lock on the baton, lock on the baton, lock on the baton. And if you want to lock, you want to do a bigger lock like you're doing out here, and a macro lock, make this all atomic, lock between two operations here, that's fine. Sync root, I'll give you my baton, but no way am I going to give you back a reference to my queue. That's my private internal data structures that I want to work with and that kind of thing. So anyway, I don't know why Microsoft didn't include this synchronized feature when they created the generic class libraries. But they didn't, so I'm sure there's some blog I could look up. One thing you could try to do is say, well, I'm going to inherit from Q of t. So then now we could say, well, Q of t or Q of int, and then Q of int could be, it could be the synchronized one, or it could just be the regular one. All right, and that's fine and dandy, except there's a slight problem. I'm hitting Control minus there to go back. Let me bring this back to our synchronized Q. We inherited Q here, but in order to make this behave properly, I need to override all these methods. You can tell I'm already implementing them, but now I need to put override in front of all these. Well, I guess I can type a little bit or copy and paste it, but then I should. Let's see, does that? Yeah, of course it doesn't build. Look, I'm going to highlight. NQ cannot override inherited member NQ because it's not marked as virtual, abstract, or override. Anyway, Q, there's nothing really overrideable here. I can get IntelliSense to help me out here. I'm going to say override and hit space. Nothing's virtual in the Q class besides the built-in object equals get hash code and toString. But none of these like important methods that we need to override are overrideable. So basically it's my way or the highway. You're either going to be synchronized or you're not. You notice it's just kind of a copy paste there, and we could use some design patterns to get around that, but I don't want to get into that in this video. I do want to point out though that now anytime you want to use any of the functions on this synchronized queue, go ahead. But if you want to call one function and then another independently, but you still need them to be synchronized together as we do here, then you need a lock on the same thing that the actual queue is using for its locking.